Hello, everyone. So today we're going to talk about the stereocenters present in a molecule. And the molecule that I've chosen today is a cholesterol molecule. Okay, so what we see here is a molecule of cholesterol, right? And cholesterol is that bad thing that makes us sick when we get older with age, right? And it comes from trans fats from foods that we eat, which are unhealthy, and exercise actually helps us maintain the level of cholesterol in the body, right? So this is that giant molecule which is responsible for diseases. Okay, so this is how it looks like. Before we get into the stereocenters, let's actually look at the molecule really quick, and then we'll talk about the stereocenters. So if you look at the first molecule, right, or like the first ring over here, this ring actually is a six-membered ring, right? We see that it's a six-membered ring, and we see that it's not actually a, it's not a, just give me a second, very, it doesn't have a great chair conformation, right? And the reason for that is the adjacent ring attached to it right over here has a double bond present in it, which is kind of affecting the conformation of that first six-membered ring. It is kind of like a boat conformation, but not very much a chair conformation, right? And then the third ring right over here is a six-membered ring again, and that ring, however, is a very nice, right? This ring over here is a very nice chair conformation ring, right? That is the third ring. And the second ring, as we can see here, is pretty crooked because of the presence of that double bond in the second ring. Okay, and then the fourth ring right over here is a five-membered ring, right? With the CH3 coming on top, and then there is this entire branched structure coming off of the fourth ring, which is a five-membered ring. So this is an entire fused cyclic structure for the molecule of cholesterol, which we are all very aware of. We know the molecule, and we know the benefits, and we know what happens when we don't have it under control, or when this molecule is not regulated in the body. We know all about that, but this is actually the structure of the molecule. It's pretty massive, right? Okay, now let's go back to talking about the stereocenters present in the molecule. Okay, let's go over here. So if we go back to the drawing board, or if we go back to the plane of a paper, there we see that this is actually how it's drawn when we see the molecule of cholesterol, right? So now let's talk about stereocenters and what actually is a stereocenter, first of all. So stereocenter is an atom, okay, which has four different attachments. So it can be a center which has four different attachments. So it doesn't necessarily have to be a carbon center. It can be any other atom, for example, nitrogen, having four different attachments, and you would call that center a stereocenters, okay? And a little short cut to like figure out or disregard the molecule or disregard the center as a stereocenter is whenever you see a CH2, right? Now that carbon center has two of the same attachments, so that H's, and whenever you'll be given like a large molecule and you have to find out how many stereocenters are present in that molecule, right? You will see a lot of them will be CH2s because a lot of the attachments or a lot of carbon centers in complex structures are CH2. So your eyes should be quickly figuring out where those CH2s are and just disregarding them as stereocenters, because the two H's are exactly the same. And because they are the same, they're by definition not stereocenters, right? And the same thing with CH3. Again, the same thing, the three H's are exactly the same. And because they're exactly the same, right, you would disregard that carbon center as a stereocenter, so it's not a stereocenter. So you see that carbon with the CH3, that's not a stereocenter. This carbon over here, not a stereocenter, right? And how about this carbon over here? So this is a CH2, right? Sometimes, actually a lot of times, chemists don't like to write a lot of H's on the molecules because there are a ton of H's, right? So you have to be able to figure it out yourself how many H's are present on the molecule or on that carbon, whether they're 2 or 1, by filling up the valency of that carbon. And you have to know for that every carbon is supposed to form 4 bonds, right? And if you don't see visibly drawn 4 bonds, if you see visibly drawn 3 bonds, which just means the 4th bond is a hydrogen. If you see visibly drawn 2 bonds, which automatically means that the rest of the 2 bonds are hydrogens, right? So then on this carbon, we see 2 visibly drawn attachments. So the rest of the 2 bonds are just hydrogens. And because they are the same, that would be excluded as a stereocenter. It's not a stereocenter. Again, the same thing over here. That's also a CH2 excluded as a stereocenter. CH2 excluded as a stereocenter. Excuse me. Also excluded as a stereocenter, excluded as a stereocenter, excluded as a stereocenter. Again, CH2, right? Because 2 attachments and there are 2 H's present on them. Excluded as the stereocenter, there are 2 H's present on it. Excluded as the stereocenter, again, 2 H's. Not a stereocenter. There is 1 H here, okay? If you do talk about this carbon center right over here, so there is 1 H because that carbon center has 3 attachments, right? So there is 1 here, 1 here, 1 here, and the 4th one is a hydrogen. So there is only 1 attachment, which is a hydrogen. And the other thing is there's 1 CH3 over here, right? And there's a CH3 over here. So now that carbon center has 2 attachments, which are CH3s, right? And that's why, again, there are 2 attachments which are the same. So again, excluded as the stereocenter, it's not a stereocenter. So we see that there are a lot of these centers which we have quickly identified as not stereocenters, right? Okay, now let's talk about this carbon atom, which we also see has a wedge coming off of it. So how about this attachment and this attachment? These are 2 attachments present on this carbon atom, and these are very different. These are very different carbon attachments. They're not the same. They're different, right? And then so 2 different attachments, third different attachment, which is the OH, and the 4th different attachment, which is then the H, right? And that's why this carbon center has 4 different attachments, and that's why that is a carbon, or that carbon is a stereocenter, right? Okay, we already disregarded this one as a stereocenter, and this one as well, not a stereocenter. Let's think about this one, right? So this carbon center has 1 attachment on the left, right? 1 attachment on the right, and they're very different because, you know, if you go to the right, the first attachment center has this branching coming off, and which is not the same as the attachment on the left. It doesn't have anything like that on the right. So that would make these 2 attachments different attachments, right? And then the 4th, okay, this is the 3rd one. This is the 3rd attachment, which is right over here, this carbon, branched carbon, and then the CH3, which is the 4th one. So that also then has 4 different attachments, and that would make that carbon center as a stereocenter, right? How about the next one right over here? Also on this carbon center, we see that there's an attachment over here, attachment over here, which are very different attachments, right? And then there is an attachment over here. So this is the third attachment, also different than the first two. And then the fourth attachment is the hydrogen. So there all are four different attachments that would also make that carbon center a stereocenter. Okay, how about this one? So again, the same concept, same logic. One attachment, right? This is the second attachment. This is the third attachment. And they all are very different because they have different connectivities. They're connected themselves to different atoms, right? And then this is an H here, which is the fourth attachment. So then that carbon is also a stereocenter because that has four different attachments. How about this one? All right, again, this is one attachment center. This is the second attachment center. This is the third one. And this right over here is the fourth one. So they all, again, that carbon center also has four different attachments. So this is ACH2 disregarded, CH2 disregarded. How about this one right over here? One attachment, second attachment, and then this is the third attachment. This is the fourth attachment, which is the CH3. That would also make it a stereo center. And then how about this one? I'm going to go over it really quickly now. So first attachment, second attachment, and they're different. Third attachment is different. Fourth attachment is different. That would also make it a stereo center. So then that is also a stereo center. How about this one? Right. Same thing, first attachment and the second attachment, the third attachment is CH3, and the fourth, which is hidden, it's not visible. So we kind of have to know that the invisible one is already the H right over here. So then that one is a fourth attachment, which also is a different one that would make it a stereo center. This is ACH2, not a stereocenter, not a stereocenter, not a stereocenter. We've talked about these before. Again, not a stereocenter, has two CH3s. All right. Did I miss any stereocenter? 1, 2, 3, 4, 5, 6, 7, 8. So in this molecule, we got 8 stereocenters. So this is okay. One thing I just wanted to mention that whenever we have carbons which are double bonded, you cannot have on a double bonded carbon, you cannot have 4 different attachments, right? And that's why we wouldn't even consider that carbon center to be a stereocenter because they're double bonded. Okay. All right. So at this in this molecule, we have 8 stereocenters. And this is the procedure to find out how many stereocenters are present in a molecule. So whether you're given cholesterol or you're given any other complex molecule or even a less complex molecule, you would go over the molecule using the same procedure to find out if the molecule has stereocenters or not, first thing. And if yes, then you can find out how many stereocenters are actually present in the molecule.